Okay, so now we're going to get into some indefinite integrals where we're going to have to do some algebra first. And the first one is going to be where we have to complete the square. So let's recall how we complete the square. It has to be, of course, on a quadratic of the form ax squared plus bx plus c, where the coefficient in front of the squared term is a positive 1. So for example, if I have x squared minus 4x plus 5, what we're going to have to do is we're going to group the first two terms, the x squared and the x term. Pull away the constant. So how we complete the square is we take half of the coefficient here of the x term, half of 4 is 2, squared is 4. But because we really don't have an equation, we have to subtract off 4 to be fair. And what we've ended up with is something that we have started with. X squared minus 4x plus 4 plus 5 minus 4 gives me all that back. You do not, when you complete the square, you take half of this term, like I said, which is 2, squared is 4. So we add 4, but we don't add 4 again because we don't have an equation here. We don't have an equal sign. So to be fair, if we added 4, we have to take off 4 because that's like adding 0. But what we've created now is a perfect square trinomial. So how we get that is this: to factor into the square root of x squared is x, the square root of 4 is 2, the sign in the middle goes in the middle, square it, plus 1. Okay, and that's going to be of our form, say for tangent inverse, where the u would be this, and the constant is the 1 already. Suppose we have negative x squared plus 6x. And there's no constant, and we're going to complete the square. You cannot complete the square where the leading coefficient is a negative 1. Remember, in order to complete the square, that leading coefficient has got to be a positive 1. So we're going to take out the negative, and if we take out a negative, this will become minus 6x. So that when we distribute this back, we get this up here. So half of 6 is 3, squared is 9. So this term here will always be positive because we're squaring it. But I really haven't added 9 to this side. I really have a negative 9 because when I distribute this through, I get negative 9. So to compensate for adding a negative 9, I really have got to add 9 then. And what this would come down to is the negative quantity of, this is a perfect square trinomial. The square root of x squared is x. The square root of 9 is 3. The sign in the middle goes in the middle. Square it. Plus 9. Now this will be in the form of our sine inverse one, where this is the constant, this is the variable piece, but it's got to be all inside a square root. Okay? So I just wanted to go over quickly how you complete the square. The leading coefficient has to be a positive 1. You group the first two terms, pull away the constant, take half of this, square it. This will always be a positive, but you have to subtract it off from the constant because of the fact you don't have an equation. When you have the negative in front, pull out the negative, and then you have x squared minus 6x. Half of 6 is 3, squared is 9. This is really like subtracting 9, so therefore you have to add 9. And then do your, this factors into x minus 3 squared, put the negative in front, plus 9. Okay? So now let's tackle an integral. So first, let's do 2 dx over x squared minus 6x plus 13. So we really think that we would try u substitution. You would try to use to be the bottom, and du would be 2x minus 6 dx. Now I could factor a 2 out, but then I don't have an x minus 3 dx in the integrand to call that my du. So therefore, some other method would have to work. And the hint is when you have this quadratic in the denominator, complete the square might be helpful here. So what I'll do is I'm going to take out the constant of 2 and just put that in front. And I'm going to take this quantity, x squared minus 6x plus 13, and complete the square. Group the x squared and the 6x. Pull away the 13. Half of 6 is 3, squared is 9. But because I've added 9, I have to subtract 9. And notice, all of this combined does give me back the original problem. This is a perfect square trinomial. It factors into x minus 3 squared. The square root of x squared is x. The square root of 9 is 3. The sign in the middle goes in the middle, square it, plus 4. So now, this is of the type of a variable squared plus a number, which is of tangent inverse. So what I have now is 2 dx of x minus 3 squared plus 4. Okay? And notice that this squared, and then adding 4 would give me this back. So this is equivalent to that algebraically. Before I choose my u and using the tangent inverse one, I have to make this constant a 1. So I'm going to pull out that 4 and make it 4 times 1 plus 1/4 times x minus 3 squared. I think that's good. So now I get 4 times 1 is 4. 4 times 1/4 is 1 x minus 3 squared. This is really 1/4 in the bottom. Well, it's really 1/4 right here. So just put that in the front. And now I have dx over 1 plus 1/4 x minus 3 squared. Now that I have the constant of a 1, I can choose my u. U is going to be the square root of the variable piece, which is 1/2 of x minus 3. The square root of a quarter is a half, and the square root of that is x minus 3. du is just 1/2 dx. You could distribute this to get this to become 1/2 x minus 3/2, but you could just see that the derivative of this would be 1/2 dx. So I'll go back and put a 1/2 in and take out a 2. This will become my du. This is 4 over 4, just 1. So I'm going to end up with du over 1 plus u squared, because this squared gives me that. And that is tangent inverse of u now. So that's tangent inverse of u plus c, but u is 1/2 x minus 3/2 or that. So my final answer would be then, running out of room, it would be tangent inverse of 1/2 x minus 3, close it, plus c. And there'd be my final answer. Okay? Next. Example number 2. The indefinite integral of dx over the square root of 4x minus x squared. So don't now assume that everything is going to entail complete the square. So here, if I chose u to be the inside stuff, du would be 4 minus 2x dx. And I don't have that at all in the integrator. So u substitution would not work as it stands. So I'm going to just focus on the inside and pull this out. And again, we have a quadratic, so let's think complete the square. To complete the square, I'm going to take out a negative to make this x squared minus 4x. Got to take out that negative. This has to be a 1. Half of 4 is 2, squared is 4. But you have to think, you really didn't add 4 because you have a negative out here. You really have added a negative 4. So therefore, I'm going to have to add 4 in this case. It makes sense. You can always check yourself, because when you distribute back, you should get this. So I do get negative x squared plus 4x minus 4 plus 4. They drop out, and I have that. So I'm going to rewrite that as 4 minus x squared minus 4x plus 4. Well, we know that that factors into 4 minus the quantity x minus 2 squared. So now this becomes the indefinite integral of dx over the square root of 4 minus x minus 2 squared. Okay? So again, this is algebraically equivalent to this. This is of the type a squared minus u squared. The number minus the variable of x squared is sine inverse. I have to make this a 1. So I'm going to factor out a 4 and have 1 minus 1/4 x minus 2 squared. And then the square root of 4 is 2, and that can come on the outside. So what I'll have now is, this is the square root of 4 is 2, but it's in the bottom, so it's 1/2 of dx over the square root of 1 minus 1/4 the quantity x minus 2 squared. Okay? So now that I have the constant, which is a 1, I can choose my u. My u is going to be the square root of the variable piece, which is 1/2 of x minus 2. Du is 1/2 dx. So I'm going to put in a 1/2 and take out a 2. So what I have is this will become my du over the square root of 1 minus u squared. And 2 over 2 is just 1. So now I get sine inverse of u plus c. U is 1/2 times x minus 2 plus c. Okay? So yes, when we do the complete the square, they will mold into the type of sine inverse or tangent inverse. Okay? Next is the indefinite integral of dx over the square root of 8 plus 2x minus x squared. So again, if you try and choose u to be the inside stuff, it's not going to work because you won't have the derivative in the integrand. So this will entail a rewrite. Rewrite the inside as negative x squared plus 2x plus 8. Okay? Again, separate the constant. So put that constant on the back burner. You can't complete the square. This is a negative 1, so we've got to factor out that negative. Half of 2 is 1. Squared is 1. But I really haven't added 1. I really added a negative 1 because this times this is negative 1. So to be fair, I'm going to have to add 1. Because again, the result here is not really adding 1. It's really adding a negative 1, which means I'm going to have to add a 1 over there. And notice that if I distribute that minus sign through, everything is equivalent to this. So what I end up with is 9 minus the quantity x squared minus 2x plus 1, because this is 9. So it's 9 minus that. And this is equivalent to x minus 1 the quantity squared. So now inside, this becomes the square root of 9 minus x minus 1 squared. Okay? Looks like sine inverse, but I can't choose u until this becomes a 1. So I'm going to factor out the 9, put in a 1/9. Now the square root of 9 is 3, but it's in the bottom. So I'm going to make that now a 1/3 in front. And this will become 1/3 of dx over the square root of 1 minus 1/9 of x minus 1 squared. Now I can choose my u to be the square root of that. du is 1/3 dx. Put a 1/3 in, take out a 3. So now on top, this will now give me du over the square root of 1 minus this inside stuff, which I call this is u, so u squared is that. And that is, well, that's just 1. This is exactly sine inverse of u plus c. So it's going to become sine inverse of 1/3 of x minus 1 plus c. And there are 3 great examples on completing the square. What I'd recommend you do is to write down the problem from scratch again, and now that you have written down the solution, is to rework it without looking at the solutions.